In this video, I'm going to show the example of how we can use sets and hash tables to determine whether two sets are disjoint. For the first example, I'm going to remove 7 from set 3. Now what I'm going to do is I will be encouraging you to find the bigger one and hash that table. The reason why we'll do this, and I'll discuss in more detail in the next video, is so that we can avoid excessive rehashing. In this case, what's going to happen is this particular set has 7 elements. When we learned in class, and I will reinforce again when you code, is that we're going to take this size and multiply by 2. This is going to give us 14. Then, using the next prime function, the result is 17. And what you'll see when you actually run the code is that the hash table in standard unordered map will also be size 17. So using our understanding of linear probing, what's going to happen is we would have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So we would have 17 buckets. So what's going to happen is we would go through all of the elements in set 4 and determine the actual buckets based on linear probing. So 34 is 17 times 2, and so 44 would end up in bucket 10. 2 is going to end up in bucket 2. 17 times 3 is going to be 51. So 57 is going to be 6. 6 would hash to 6. Linear probing takes us to 7. 19 mod 17 is going to be 2. Can't do 2, so 19 will be in mod 3. 17 is taken, so 7 will be here. And then 18 mod 7 is 1. So this becomes our hash table. We see that with distribution, we have a couple of what we're going to call clusters. And later in the semester, we are going to be learning about double hashing and quadratic probing to reduce those clusters. But for now, we see that with proper sizing, we had minimal collisions and we didn't need to rehash. So now what we would do is we would go through and use that same hash function to look all these elements up. 10 is not there, 1 is not there, 22 is going to be 7, that's going to be 5. We see that that's not there, and 5 also goes to the same location. We were able to claim that this is big O of n because each insert was big O of 1, which means n inserts becomes big O of n. And then n finds, each find is big O of 1. Therefore, we have this element, so this becomes big O of n plus big O of n. And what we learned is that this becomes 2 times n, and then this constant becomes big O of n itself. So the only difference is, well, what happens if I insert 7 here into that hash? What will happen is, using the hash function, it will initially go here. It will say, all right, I'm going to look down here. It finds 7, and we say that because we found it, it is not disjoint.